And then, in the lab, we stumbled upon this wonder. It's the whirligig, or a buzzer, or a run-run. A couple of strings and a little disc, and if I push, it spins. How many of you have played with this as a kid? This is called a button on a string. Okay, maybe 50% of you. What you didn't realize, that this little object is the oldest toy in the history of mankind. 5,000 years ago, we have found relics of this object hidden around on our planet. Now, the irony is, we actually don't understand how this little thing works. That's when I get excited. So, we got back to work, wrote down a couple of equations. If you take the input torque that you put in, you take the drag on this disk and the twist drag on these strings, you should be able to mathematically solve this. This is not the only equation in my talk. 10 pages of math later, we can actually write down the complete analytical solution for this dynamic system. And out comes what we call Paperfuge. That's my postdoc, Saad Bamla, who's the co-inventor of Paperfuge. And to the left, you see all the centrifuges that we were trying to replace. This little object that you see right here is a disk, a couple of strings, and a handle. And when I spin and I push, it starts to spin. Now, when you realize, when you do the math, when we calculate the RPM for this object, mathematically we should be able to go all the way to 1,000,000 RPM. Now, there is a little twist in human anatomy because the resonant frequency of this object is around 10 hertz, and if you've ever played piano, you can't go higher than 2 or 3 hertz. The maximum speed we've been able to achieve with this object is not 10,000 RPM, not 50,000 RPM, 120,000 RPM. That's equivalent to 30,000 G-forces. If I was to stick you right here and have it spin, you would think about the types of forces you would experience. One of the factors of a tool like this is to be able to do diagnosis with this. So I'm going to do a quick demo here where, so this is a moment where I'm going to make a little finger prick, and a tiny drop of blood is going to come out. If you don't like blood, you don't have to look at it. Here is a little lancet. These lancets are available everywhere, completely passive. And if I've had breakfast today, that didn't hurt at all. Okay, I take a little capillary with a drop of blood. Now this drop of blood has answers. That's why I'm interested in it. It might actually tell me whether I have malaria right now or not. I take a little capillary, and you see it starts wicking in. I'm going to draw a little more blood. And that's good enough for right now. Now, I just seal this capillary by putting it in clay. And now that's sealed this sample. We're going to take the sample, mount it on Paperfuge. A little piece of tape to make a sealed cavity. So now the sample is completely enclosed. And we are ready for a spin. I am pushing and pulling with this object. I'm going to load this up. And you see the object starts spinning. Unlike a regular centrifuge, this is a counter-rotating centrifuge. It goes back and forth, back and forth. And now I'm charging it up. And you see it builds momentum. And now, I don't know if you can hear this, 30 seconds of this, and I should be able to separate all the blood cells with the plasma. And the ratio of those blood cells to plasma, already, if you see right here, if you focus on this, you should be able to see a separated volume of blood and plasma. And the ratio of that actually tells me whether I might be anemic. One of the aspects of this is we build many types of paperfuges. This one allows us to identify malaria parasites by running them for a little longer, and we can identify malaria parasites that are in the blood that we can separate out and detect with something like a centrifuge. Another version of this allows me to separate nucleic acids, to be able to do nucleic acid tests out in the field itself. Here is another version that allows me to separate bulk samples. And then, finally, something new that we've been working on, to be able to implement the entire multiplex test on an object like this. So where you do the sample preparation and the chemistry in the same object. Now, this is all good, but when you start thinking about this, you have to share these tools with people. And one of the things that we did is we just got back from Madagascar. This is what clinical trials for malaria looks like. You can do this while having coffee.